Have you ever stopped to wonder how a machine, something that really only gets ones and zeros, can possibly make sense of human language? How does something like ChatGPT go from the words we type to, well, to something that feels like understanding? Today, we're going to pull back that curtain on one of the most fundamental and, frankly, coolest processes in modern AI. Okay, let's just dive right in.
So let's start with a really simple sentence. The cat sat on the mat. To you and me, the meaning is crystal clear. But for an AI, this is a puzzle. It's a puzzle that has to be solved by translating our world of language into its world of numbers. And we're going to follow this exact sentence on that journey.
And here's the roadmap for that journey. We'll start with the raw text, the sentence itself. Then we'll see how it's broken down into pieces called tokens, how each token gets a numerical ID, and then, this is where the magic happens, how it's transformed into something called an embedding. This four-step process is absolutely key.
All right, first things first. An AI doesn't read a sentence the way we do, from left to right as a whole. Its very first job is to chop it up into manageable pieces. Here it is again, our sentence in its original human-readable form. This is our starting line.
The AI model uses a process called tokenization, which basically just breaks the sentence into these smaller units, or tokens. Now, in this simple case, each word is a token. But here's a really clever trick. For more complex words, like, say, playing, a model might break it into play and ing. This helps it understand grammar, and can even help it deal with words it's never seen before. Pretty smart, right?
Okay, so now we have our bag of tokens. The next step is to convert them into numbers, because at the end of the day, computers speak the language of math, not English. So the AI has this massive vocabulary, like a giant dictionary, where every possible token has its own unique ID. The becomes 101, cat is 205, and so on. Now, something that's really interesting here is that both the capitalized the and the lowercase the get the same ID, 101. That's a common trick to make sure the model treats the same word the same way, no matter how it's capitalized. Just like that, our sentence is now a sequence of numbers.
But hang on, is this really understanding? I mean, look at this. The ID for cat is 205, and the ID for dog might be 876. These numbers are totally arbitrary. They tell the model that the words are different, sure, but they carry zero information about how they're related. We know that cats and dogs are both pets, they're both animals, but to the model, they're just two random, unrelated numbers. This just isn't going to cut it for building real understanding.
And this is where the real breakthrough happens. To solve this whole meaning problem, we introduce a concept called embeddings. This is the step that truly bridges that gap between just words and actual understanding.
So what on earth is an embedding? Well, instead of using just one arbitrary number, we represent a word with a long list of numbers. This list is called a vector. And you can just think of a vector as a set of coordinates. Each number in this list represents some tiny aspect of the word's meaning, which the AI has learned by analyzing billions and billions of sentences.
Now look at this. Check out the embedding vectors for cat and dog. They're not identical, of course, but look at how many of the numbers in their lists are really similar. This is how the model numerically captures the idea that these words share a lot of meaning. That they're both animals, they're both pets, and they show up in similar sentences. This is meaning turned into math.
A really great way to think about this is to picture a giant, multi-dimensional map of words. Every single word has a specific location on this map, and its location is decided entirely by its meaning. So on this map, words that have similar meanings, like king and queen, they get placed very close to each other. Their vectors, their lists of coordinates, are numerically similar, which makes them neighbors in this conceptual space.
And on the flip side, words with totally different meanings like cat and car, they're located way far apart on the map. Their embedding vectors will be very different, and that reflects that they don't share much context. It's this spatial relationship, this map, that's how the AI really starts to grasp nuance. So let's just take a second to recap why this whole transformation from a simple ID to a complex vector is so incredibly important.
So here's the bottom line. Embeddings are the bridge. They are the thing that provides the meaningful numerical input that neural networks need to even function. They capture all those subtle relationships between words, which allows a model to go way beyond just memorizing things and to actually start understanding new sentences it's never seen. This is the foundation that makes everything from Google Translate to your favorite chatbot actually work.
But creating these rich, meaningful vectors, that's not the end of the story, not even close. In fact,
it's just the beginning. They are the fuel for a much, much more powerful engine.
See, these embedding vectors get fed into these super sophisticated models, the ones you hear about like GPT, which are known as transformers. And inside that transformer, there's this powerful mechanism called attention that looks at all the word vectors in a sentence at once. It figures out how sat relates to cat and mat to build a really deep, contextual understanding of the whole phrase. And it all starts with these powerful little embeddings.
So, we've seen how our text gets translated into a numerical language that an AI can finally understand. Embeddings build that absolutely essential bridge from our world of words to the machine's world of numbers. But that leaves us with a really fascinating question. What kind of understanding is actually happening on the other side of that bridge?